Hello students, welcome back into my channel. In this video, I would like to discuss an important topic in mathematics, and that is about function. All right, I will start with the introductions of this lesson, and this is about relation and function. A relation is any set of ordered pairs x and y relating an independent variable, typically x, to a dependent variable, typically y. So if you look this figure, that this is a function, is a relation, and look that this relation, that this one and this one are function, and while this one and this one is not function. Okay, why? Because if you evaluate a variable or elements, sorry, not variable, elements of this set has uh, two pairs, okay, of the second set as well as one. Okay, so the domain has two element of domain has two elements of range. That is not function. It should be actually every element of domain have one pair, okay, elements on the range area. If a function y equal ax plus n, this is a linear function, okay, with a not equal to 0, the linear function, this is the requirement, because if a equals 0, this is not linear function. This is, if a equals 0, this is not a linear function, but this is the constant. As well, if y equal ax squared plus bx plus c, this is the quadratic function, it should be a not equal to 0. If a equals 0, it means this is not quadratic function, but this is the linear function. Based on the understanding, the definitions of relation of function, that this is the independent, uh, and this is the dependent, based on this information. Okay, this is the independent and dependent variable as well. For the quadratic equation, the quadratic function, I mean, x is the independent variable and y is dependent variable. So y depends on the value of x, as well as this, the linear function. Now, regarding domain and range, domain is the set of all possible inputs for the function. So if we have function, linear function, for example, fx ax plus b, so when we input domain into this function, we can have the range elements. Okay. Every function, every domain will be implications for the range value or the range elements. So that is domain. How about range? Range, the difference between the lowest and the highest values. Okay. So range, actually, the elements produced by domain. Look, for example, this is domain, this domain area, and this one the range area. How we got the elements of range through this function? Fx equal x plus 1. When you input minus 1 into here, like this, minus 1 is going to be minus 1 plus 1, and it is 0. So therefore, this is 0. When you input x becomes 0, this is going to be 0 plus 1. So this x becomes 0, and it is 0. So therefore, this is 1. If the domain is 0, the range equal 1. If domain 1, the range equal 2. If domain 2, the range equal 3, and so on. You can continue to the next domain, the next number. A function is a special type of relation where each value of the independent variable yields only a single value of the dependent variable. So these are the relation, and if you look this relation, that this is function, okay, this is function, and this is not function, because one domain has two output, okay, y and z. So if the relation like this is not a function. Okay. How about graphs? Graphs of a function and not function. Okay. Very simple to determine whether the graph is a function or not function. Like this. So every domain just have one range. Like this. Yeah. This is not a function because this domain has two. Okay. In the range area, this is the range area. Y this is range, and this is x domain, x y. So y-axis is the domain axis, and x-axis is the y-axis is the range axis, and x-axis is domain axis as well. This one. This is not a function. Why? Because look that one domain has two elements in range area. Let me check also as one. Okay, this is a function because uh, one domain elements has one elements in range area. This one. Okay, elements one range. As well as one. Okay, it has one and it's one. Okay, about this, uh, it has three. One, two, three intersection. It means three elements on range area. One, two, three. So therefore, this graph is not graph of a function. This is a graph of a function because it just have uh, one element, okay, on the range area as well. This one element of domain has one element of range. The output as well as one. The output of this domain, one element of domain has only has one output in the range area. Okay. This one also not a function. Why? Because this element of domain has two, okay, two output in range area. So this graph is not a function. Now about adding and subtracting function. If there are two function of a linear function, for example, 2x plus 4, and another function gx, 3x minus 5. So if fx plus gx would be 2x plus 4 plus 3x times 5. And it's going to be 5x because 2x plus 3x and 5 minus 4 minus 5 equal minus 1. While fx minus gx becomes 2x plus 4 minus 3x minus 5. It's going to be 2 minus 3 minus 1x. 4 minus minus 5 becomes 4 plus 5, 9. And if gx minus fx, it will be 3x minus 5 minus 2x plus 4. So 3x minus 2x equal x, and minus 5 minus 4 becomes minus 9. So you can solving also if the adding and subtracting of quadratic function or polynomial function. Next up, about multiplying function. For the multiplying function, for example, if fx equal to x plus 5 and gx equal x squared, okay, this quadratic function. So if fx multiplied by gx, it's going to be 2x plus 5 times x squared and becomes 2x cubed plus 5x squared. This the result. And how about if quadratic function and quadratic function is fx equal x squared plus 1 and gx equal 2x squared minus 3. So fx multiplied by gx is going to be x squared plus 1 times 2x squared minus 3 becomes 2x or 4 because x squared multiplied by 2x squared. And after that, minus 3x squared plus 2x squared minus 3. 2x or 4, and this is minus x squared minus 3. Okay, next continue. Inverse function. To have an inverse function, a function must be 1-to-1 function. A function is said to be 1-to-1 functions if whenever fx1 equal fx2. It implies that x1 equal x2. This means that for each y value, there's only one x value. That is the understanding of one-to-one function. So inverse of one-to-one function, like this, you can compare this the main function, and this is the inverse function. So if the main function x to domain x, the range 8, if the domain y, the range 9, if the domain z, the range 10. If inverse, okay, 8 becomes domain, 9 becomes domain, 10 becomes domain, and the range of x of 8 is x, 9 becomes y, and 10 is z, the range. So look, this 1-to-1, and this is not 1-to-1. Okay, why not 1-to-1? Because 10 and 30 has same output 3 on codomain area, on the range area. This is range area. Actually, the range for codomain. As well as one function. There's a function. This is one-to-one function. Oh, this is not one-to-one function. Even this is a function, but not input of one-to-one function. This is a bijection. Okay, and it's one-to-one function. The pairs are like this: 2,9, 4,6, 11,5. This is not pairs of one-to-one function, because if you look that this is 5 and as well this is 5. So two elements of domain has one output, 5. Okay, I would like to discuss uh, about inverse function. For example, if there is a function fx equal square root to x plus 4, how to find the inverse of this function? The first step, you need to writing this function becomes y equals square root to x plus 4. And after that, you have to set the left-hand side becomes y squared, and the right-hand side becomes 2x plus 4. If you set becomes the quadratic uh, function, that y becomes y squared, and square root 2x plus 4 becomes 2x plus 4, because you have to set like this. Okay, y squared equal square root 2x plus 4 squared. Right. And the next step is, I'll continue here, 2x equal y squared minus 4, and x equal 1/2 times y squared minus 4. So we can state that the inverse function of this function is 1/2 of x squared minus 4. So this is the inverse functions of this the main function. Okay, sorry. Yeah, this one. And if how about if the this number one, I would like to this number of this number one, number two. And how about the function like this? Fx equal 2x plus 3 over 4x minus 6. So similar with the previous one, you have to set this function becomes y equal 2x plus 3 over 4x minus 6. And after that, uh, left-hand side and right-hand side multiply y 4x minus 6. If left-hand side multiplied by 4x minus 6 is going to be y times 4x minus 6 equal. If right-hand side multiplied by 4x minus 6 is going to be 2x plus 3. After that, multiply 1 by 1. 4xy minus 6y equal to x plus 3. And after that, we are going to grouping x and x. It's going to be 4xy minus 2x, and this y grouping with 3, it's going to be 6y plus 3. Minus becomes positive because when you grouping, actually left-hand side plus 6y and right-hand side also plus 6y. So it becomes like this, plus 6y and minus 2x. Sorry. So left-hand side plus 6y minus 2x, and right-hand side plus 6y minus 2x. So this equation becomes like this. And after that, factorize. If you factorize, it's going to be x times 4y minus 2 equals 6y plus 3, or x equal 6y plus 3 over 4y minus 2. So the inverse of this function is what? Inverse of this function is what? Is the inverse is 6x plus 3 over 4x minus 2. Next, how about if you have um, function, for example, if the function uh, fx equal 2x squared, okay, plus 5, for example. So the first step, you have to set y equal to x squared plus 5. And after that, uh, rearrange this equation, becomes 2x squared minus x squared equal y minus 5. So x squared equal 1/2 y minus 5. Okay, and x equals square root 1/2 y minus 5. So the inverse function becomes square root 1/2 x minus 5. This is the inverse function. And also if you have a function, I don't know what number is one, just know number 3, okay. This is number 4. If you have the simple function like this, fx equal 3x plus 2. So set becomes y equals 3x plus 2. And after that, rearrange this function, becomes 3x equal y minus 2. So x equal 1/3 y minus 2. So the inverse function is 1/3 x minus 2. This is the inverse function. Okay, and the next is graph of inverse function. Inverse function actually has graph. And if you look this graph, look that this is the fx, and if you sketch the fx inverse, this is the graph of inverse of this function. And look that y equal x, straight line y equal x, okay, is the reflector. So this is the reflector, okay, reflector of this graph, okay, fx. And this is the inverse function. As well, this an example of the main function, okay, fx equal x squared plus 2. And this is the inverse of this function. If you sketch, it becomes like this, the graph. As well, this is the inverse functions of this graph. Pay attention that this is y-axis, this is x-axis, okay, and when you sketch, this is the x-axis, this is the y-axis. So do not confuse. But if you would like to sketch on the same diagram, the Cartesian diagram, you can sketch on the same diagram. As well, this is the another graph of a function and the inverse function. Not clear, but this is, you can see that the reflector, the reflector line is y equal x. Okay. This is the main function and this is the inverse function. So actually, I would like to tell you that the main functions, we can sketch the inverse function. As you can sketch the main function, also you can sketch the inverse function. Like this function, the main function is y equal 3x plus 1, and the inverse function is 1, x minus 1 over 3. Okay, so that is our lesson about introduction of a function.